Everything NASA changed after Artemis I and how it paid off for Artemis II. Artemis I was a success, but NASA still changed a surprising number of things before putting humans on Artemis II. Artemis II wasn't just Artemis I with astronauts. It was the culmination of all the changes that NASA applied following the first mission. And now that Artemis II is over, we can look back at those changes in a very different way. Because Artemis I proved that the system could fly, but Artemis II showed whether NASA had actually learned from that first flight. Artemis I was the first flight test of the SLS Space Launch System rocket and the Orion capsule. Despite this being an uncrewed mission, Artemis I represented the first moon-bound mission of a human-rated spacecraft since the Apollo missions. It launched in November 2022 as a 25.5-day, 2.25 million kilometer voyage around the moon. The objective was to make it around the moon in distant retrograde orbit to prove the hardware's reliability before being boarded by humans. Through Artemis I, NASA proved that their modern architecture worked and that it was close to being ready for human travel. What was Artemis II? Artemis II was the first crewed mission of the Artemis program. It sent 4 astronauts on a 9-day mission around the moon. It launched April 1st, 2026 and represented the first crewed lunar flyby in over 50 years, so the stakes were completely different. Success doesn't mean no changes are needed. Artemis I was not a failure that NASA had to fix. It was a real-life test program and post-flight analysis that naturally revealed flaws and overall room for refinement before astronauts flew. Some changes were about crew safety, and others about vehicle performance. Others were aimed at making Orion and SLS work more smoothly together. I have identified 4 key changes between Artemis I and Artemis II. A. Optical targets on the ICPS and OSA. As preparation for a crew, an important change that was made was the introduction of optical targets on the interim cryogenic propulsion stage and the Orion stage adapters. This was implemented to allow for astronaut training during Artemis II in preparation for Artemis III docking maneuvers. B. Improved navigation and communication. For Artemis II, SLS flew with a revised navigation system coupled with repositioned antennas to allow for continuous information relays with NASA ground stations. C. Emergency detection system on the ICPS is enabled. The activation of this system allows for the crew to be directly notified of any issues. Furthermore, it gives them the ability to respond along with also adding a slight delay, allowing for the safe ejection of Orion should anything go wrong. D. Strake adjustments. In response to unexpected vibrations during Artemis I, NASA elected to provide the SLS with strakes to protect the attachment nodes on the side boosters, as can be seen in the following image. Now, to be careful, we cannot say that each individual modification was personally proven one by one in some dramatic public way, but we can say this. Artemis II launched successfully, completed its crew lunar flyby, carried out manual piloting objectives in Orion, and returned safely to Earth. That means the overall process worked. Artemis I revealed where NASA could improve. NASA made those improvements, and Artemis II became the proof that the agency was not just testing hardware. It was refining it fast enough to trust it with human lives. Artemis I showed that NASA could get back to the moon. Artemis II showed that NASA could learn from that success, tighten the weak points, and send people with confidence. That is what made Artemis II more of a repeat mission. It was the upgraded response to everything Artemis I taught NASA.